the logarithmic functions. So last time we did exponential functions. Now we'll do the inverse of the exponential, which is logs. Okay. Use definition of a logarithm. Yeah. Good. Yes. So for all real numbers y, and all positive numbers a and x where a is not equal to 1. Then y equal to log base a of x is equivalent to x equal to a to the y. You can change back and forth. So the first few questions in the homework, they're going to ask you to change such and such to log form or to exponential form. Yeah. A and x. Log base a of x. So the a is the base of your logarithm, also the base of the exponential. A must be positive and not 1. All right, number 1, let me give you some properties we're going to need later. Just going to write all the definitions that we need, and then we'll start some examples. So if you have a product inside your logarithm, x times y. You know what? Before you write that, I was gonna move. I'm writing the same thing. I'm just gonna make a space. Sorry. It's improper to not define our variables. I don't know. Or x greater than 0, y greater than 0, a greater than 0, a cannot be 1, and any real number any real number the following is true or holds. There you go. Product property. If you have an argument that is a product, x times y or 2 times 5 or whatever, some sort of multiplication, you can separate them into addition. As long as with the same base though. The base doesn't change. So base A down here would be applied to would be on both. Okay. When you have log base A of two or more factors, doesn't have to be just two, you can separate them all over addition. Just make sure they have the same base you started with. So if this is log 2, then these better have 2's, right? It doesn't magically change.
Mr. Gonzalez, question.
Yeah.
Relating to the logarithmic functions, is this just pertaining to like isotopes and stuff like that, and what we've already been learning and reviewing, or is this a totally a different thing?
Well, we're doing logarithms in general, but it can be applied to isotopes, different types of decay, population growth. It just
Okay,
depends. But
so
it
it's just pretty much like they help give projected amount of numbers for certain items or certain things that we're counting, or we're I guess recording different sets of data.
yeah, if the data fits a logarithmic pattern, then we start using these types of functions. So if it has that shape or growth rate, then yeah.
Okay, sounds good. Thank you.
You need to come.
He said you were mean to him, so he stopped coming.
Huh? Oh, I know, dude.
It's because y'all didn't bring me Chick-fil-A the past 2 times y'all had it.
You're bringing us Chick-fil-A, what?
Man.
Is that what you said? The whole class?
I'll bring it on Sunday.
When they're closed.
All right.
Is that a Y?
Quotient property. X over Y. So if you have a quotient, you just change it to subtraction. Okay. So whatever's on the bottom would be after the minus sign. Whatever's on top is the first part. You can have a combination of the two, rule 1 and rule 2. You could have like 2 things being multiplied on top of the fraction and then something else on the bottom, right? Power property. What's up?
Y equal.
Here, the top,
Oh, that's.
the LOG, base A. Yeah, so it's a subscript A, letter A.
Why is it there?
Because it has to be a specific base. Like, for example, when you're doing actual problems, you have a specific number, like log base 2 or log base E. Kind of like square root, right? Could be square root, cube root, fourth root. The base is that little number. So the A is just a specific number we're dealing with. Okay, that's all.
So, Mr. Gonzalez, it's safe to say that the base A could be any number from 0 to infinity or 0 to negative infinity.
Everything above 0, but not 1.
Okay.
We miss you, dear.
So the power property lets you bring the powers down to the front, which is valuable when you're trying to solve for a variable that's stuck up top as a power. Usually that's a time variable, or when we're dealing with insurance, interest, or insurance, simple interest, compound interest, all that stuff. We have that time thing that's stuck up top. So the only way to get it down or cancel it is to introduce logs. So we define these to cancel the exponentials. I think Fig 3 is probably the most valuable one. I need to call my insurance. Now, if you put a 1 inside any log, it's going to be 0. Doesn't matter what base. If you see a 1 inside, it's 0.
And there is base will be front of or next to log, right?
Yeah, the base is always right underneath the log.
Okay, so A is the base.
Mhm.
Oh,
It's a subscript. But yeah, A is the base.
Face to face. Do you remember them?
What is it?
That I saw the sign. Face to face.
Sounds familiar. Maybe. I remember the song. If the bases match the argument, they cancel, leaving you with a 1. Or similarly, if it has a power, it'll cancel, leaving you just with the power that's up top. So if you have an R up here, you're only left with the R. So whatever is the power, that's all that's left. So technically, this is just an extension of 6. Back to the spot. Okay, you guys done with this page? No, not yet. No rush.
Mr. Gonzalez, I have a question. The question is pertaining to the logs, right? Okay. You said log A, right?
Mhm.
It's just an expression, correct? So is there any two logs in existence that if you would see them together, like let's just say it's a problem that we need to figure out. If you see two certain logs together, um, will that cancel each other out no matter what the bases are, or what are the directions they give us to carry out to get our answer?
But they would only cancel an exponential.
Okay.
But they will also cancel out. Well, see right here, this would be like an exponential function inside a to the r.
Okay.
Log a and a cancel, leaving you with r. These same thing. That's the only time logs will cancel. The other time would be if it's a 1, then you get a 0,
Okay.
but no other time.
So let's just say, for instance, I have that quotient property one, log subscript A, X over Y
Yep.
with the, I guess this base of logarithm of A, which would be a log, subscript A to R, that wouldn't cancel, or that wouldn't even be a question they would challenge us with.
Like if you had an r on this one, like out here.
Yeah.
No, yeah, you will see that. You will see stuff where you combine all of them at the same time, like 1 through 3.
Okay.
So you have a
And-
power, a quotient, and a product. And then you
And-
gotta just expand it.
Will those be the most common ones that you see like being combined?
You'll see all of them. I don't know what's the most common at the moment, but you will see for sure each one. But I think the harder ones would be when they combine multiple.
Okay, thank you.
All right, move on to examples. So the homework is going to start with you applying the definition. Oh, there's a thing up top.
So there's nothing next to the 6, or is that just?
It's basically the same thing as 5. It's just Honestly, this is a specific case when R is 1. Honestly, you should just have this one, but the book likes to show both of them. Because it's kind of like a cancellation.
Well, just a little, it's an example, I saw six. That's
Yeah, it's just basically, you could write the same thing if you want, I guess. But meh, whatever. Who cares? Math is very strict and precise. So I'm trying to be that way. It's hard though.
That's what you gotta do. It's that, it's.
Okay, so it'll start out just like this. It'll give you an exponential, change it to log. Okay, so just look at this first definition up top. This one right here. So change this thing into this. That's it. Okay. So looking at that formula, this is the y, the power. This is the base. This is the x. The 4 to the 5th equal to 1024. That would be, okay, so we said this is the y, so f5 equals log base 4 of x, which is the 1024. That's it.
Right?
My arrow sucks though.
Minus.
That's worse.
Minus like.
That makes sense. Do you see where all the pieces came from? Okay, it's just a definition. Hmm? No, that's all we do. You just plug that in and we move on. We might need a calculator later. All right. Example 2. Let's go the other direction.
Not a tree?
Log base 3 of 9 equal to 2. Okay. So we said the base is the same base, so it'll be 3 to the whatever it's equal to. So 3 squared equal to the argument.
That number is for the That's the formula? That's the four, okay. That's the formula you need to put that number.
That's for later. We're doing this, we're using this one here. First two examples was using this definition. You can go back and forward to log or exponential. Are you guys cool on example 1 and 2?
I guess in formal, that's what you need to speak for the first time, just write down. Order.
Yeah, there's not much work you should be showing here. Right, because you're just following a definition, like a formula, basically.
Would it ever be backwards like that? Was the 5 equals log 4 to 1024?
Yeah, you could start as a log or it could start as an exponential. Depends. So go both ways. Let's do solving equations. Or basic ones using the definition. So we're still using the definition, not the properties. Do one of those and we'll move on to something else. The harder ones. Just put all the pieces in the right places, that's all. Solve the given logarithm. Okay. So apply the definition and then try to solve for x. Because right now the x is trapped inside. So apply it. So what is the base that we have? Yeah, it's gonna be 3. What is the power? Yeah. And it's equal to the arguments, right? So just solve it. So what is X? That's it. So the questions will vary in difficulty on what kind of algebra you'll need. Some are really ugly, some are super basic, like this. Okay. It just depends. But in essence, that's all you have to do is change it, do basic algebra. That makes sense? All right. 4.3. All right.
Right. Yeah, it's.
All right, so on the workbook, 4.3, page 165. Try the first first 13. And I'll help you out if you get stuck. I'll do them on here. 165. On the workbook, page 165, 1 through 12. Work on those and see if it makes sense. Workbook is pure extra credit and participation.
Was that like the entire workbook, would that include like that information? But then you were saying before that it was
Yeah, not the test review questions. That's the ones that we've done together. We finished them off. So log base 3 of 1/3. Remember we said in rule number 6, if they match up, we'll roll. So is it 7? Forget. The last 2 rules. If they match up, they just cancel. So rewrite the 3 as a 3 to the negative, or the 1/3 as a 3 to the -1. Because that's the same. And then rule number 6 tells you This will cancel and leave you with just the power by rule 6. That makes sense? Oh, it's okay. So this one you want to change 64 into some sort of fourth, if you can. Force it into a fourth. Let's do that one next. Log base 1/4 of 64. So 4 is what? 64 is 4 to the. How many powers? 4 times 4 is 8, 16 times 4 is 64, right? 3. But they still don't match because it's not a 1/4. It's a regular 4. So do the opposite of what we did on numbers on part A. Bring it to the bottom. But when you do, this becomes a -3. Is the same as this, right? Yeah, whenever you move it up or down, it changes to negative, just like this one. I moved it up, became a -1. This one, I moved it down. So basically manipulating it into looking like, until you can apply rule 6. That's all. All right, for number 2, we said whatever it's equal to is going to be the argument, and whatever is the power is what it's now equal to. So it's going to be -2 equal to log base 2 of the 1/4. So we're just applying the definition. That's it. Right, this is the base right there. Whatever you're equal to goes inside. Whatever is your power is what it's now equal to. So same thing here. Gonna be base 64 raised to this power equal to 4.
Log 2, 1/4 equals -2. Would that be wrong?
Yeah, that's fine. Same thing. Yeah. Either one. Mhm. You're right.
You, if you break it down into steps from 17.
For 7B?
Yeah.
Okay. So I'm trying to make the argument inside into a 1/4 because once they match, they will cancel. To change 64 to a 1/4. So first of all, I know it's 4 to the third is 64. Bring this down to the denominator by changing this to a negative power. At that point, they're going to cancel, leaving you with a -3, but it's best to put it on the entire thing because the formula says if it's on the entire argument, then you're good. So putting it here or there is the same.
Just a little lost in the first thing.
Oh, yeah.
So trying to go it's make it.
Hmm. Yeah. How it is.
Oh, wow, I-
It's toxic.
it is. Dogs in general, they have to shoot their walks, that should have been. Nah.
So. Okay. I'm gonna move on to something else. I'm gonna give you more time later. So example 4. Expand the logarithm. You know what, let me start slow. Log base 5 of 2x. Expand it as far as you can. What is that gonna be? So you have products. Yeah, expand.
I see the big number.
So use your product property. See how you just. You have 2 times x, separate them. That's all you're doing, nothing else.
Five. Five. Oops. And we're trying to find this.
No, we're just expanding. That's it.
Yeah. Also, where's the-
We're not solving for anything. You're just expanding.
Okay. So far,
So here you have a product on top and then a denominator on the bottom.
So now you're gonna create the property, portion property.
So the top part is the first part, right? And then minus whatever's on the bottom. That makes sense?
Property.
Can we go any further? Is that fully expanded?
Yeah.
We still have a product. Right? We separate the numerator and denominator. And we still have a product in the denominator part, 2x. So do it again. Product rule. What do we get? And what do we just do in part A? By doing what?
I think the plus. Right?
Yeah, we had a product of 2 times x. We changed it to a sum, right? Now we have it again. See what I mean? Let's just do the product, this product rule on this piece. Do you have just like this one, right? Separated like,
Oh, okay. So you would do the two.
yeah,
You have figures.
yeah. Can we go any further?
Yeah, I was thinking that you did the three part, but I wasn't entirely sure how you do this. So I mean, it's exactly the two of them. So you just what's that like?
Yeah, so try to do one thing at a time, unless you know, very comfortable. Do you see property 5 can be used? Here we did quotient. Here we did product. What can we do now? Yes, do you see that the bases match here? What happens when they're the same? What are you left with? Rule 5, I think, tells you
One.
the properties, property 5. think it's gonna be 1.
Regardless of.
Anytime they're the same, the argument and the base, they just cancel. Leaving you with whatever's on the power. This power is assumed to be 1, so you got a 1.
It's all one question.
Yeah. Oops, hold on. I made a wrong note there. All right, so you guys are cool in part B.
The loss of the same to follow this part. 5. Does I mean like that they will have because we were just talking about the first portion. It's long basically.
Yeah, 2x over 7. Okay. Log base 4 of AB over CD. So do a quotient for the top and bottom, and then see what you can do with the products. That makes sense? The first part, okay. Well, well, close, but that last part, that minus is on the entire thing, so they would both be minus. The last two. So if we do the first part, we get this, right? But then you put minus. So everything in here that comes out will have a minus.
Let's see.
See what I mean? We're just using the properties, that's all. Nothing crazy. Right, so from the beginning, we use the quotient on these two parts, separate them. Quotient is for fractions. Then we expanded these two products here and these two here using the sum of the product rule. Minus go on both. That's all we're doing. We're just expanding them. We're breaking them apart using the 6 properties. But let's do some putting them back together. So you can learn the properties. Once you've learned them, we're going to use them to solve equations. The next section. So they make sure they make sense. That's right. Questions on sample 3 or 4? All right. Let me turn the page then. Do one more and then we'll take a break. Write the expression as a single log with coefficient 1. The log a of x plus log a of y minus log a of, I don't know, w. No, base 10.
That was the blue letters.
There's no numbers here, so you cannot use the calculator. Meaning, whenever you do combinations or combining them, make sure there's no number in front, just number 1 when you're done. So get it to a single log with a coefficient of 1.
Okay, I was gonna say that would be 0, but then that's only if it's the base.
Just in front of the log, just make sure there's a 1 there. That's all. That makes sense, or
Yes. It'll be 1 times log a xy over w.
1 log a xy over w. Yeah, that's right. But you don't have to write the 1. It's just implied. To just make sure if there's like a 3 there, you gotta do extra work.
I'll just like whatever, just like x. So it's that.
Yeah. Yeah, if there's anything that's not 1 in front, you have to do an extra step. So if you have a sum, this becomes a product. Do it in steps. This is, we apply the product rule right here. Combine these two because they were plus, they turn into times. That's what the rule tells you to do. If you have a minus, then that means that these will become fractions. This is the top and this is the bottom. to the next step. Sorry, that should be W. Sorry about that. That's quotient rule. That's it. Fully combined. No number in front except a 1. We'll take a break here. Feel free to try this out whenever. You guys will take a break here. Let's come back at 5, I guess. And we'll start a new section. Maybe. Very sluggish.
Thinking about. I forget how we're combining. I was my to separate. So, all right, that's like 7 parts silly.
Nah, but I think you're getting it though. So yeah, bring the 2 up first. That's the first property.
I don't want to change that idea. It's like literally going after that.
No, what, you don't get it anymore?
Yeah, like or like something else was done to this like it's not that.
Sorry.
So I kind of start thinking like, oh, I'm getting this, and then like the next person, like, oh, I see.
I think you're very close.
So what would the bracket represent? Wouldn't you be able to?
Nothing. They're just inside the log, that's all. You can put giant parentheses if you want.
Oh, okay, that's just like separated. Them.
Yeah, I'm just saying these are in the log.
Oh.
If I don't put it, it looks like it's kind of on the side.
So what's the squared? Not go on both sides or just the first part?
Just the first part.
Oh, because it's 2. Okay. Okay.
Yeah, so it's this times this.
So it kind of comes that way, like the practice stretch board. So I was doing a lot of it pretty well. And I was like, oh, this is pretty easy. And like when I was doing tests, there's like 2 questions that I should have wrote more notes on. Just 'cause I didn't mark them down on the test themselves, like flagging it up. Mistake me if I'm not correctly. The marking or flag it on the test itself is in the case that like like more help with that specific type of equation, right? Or is that to say like there's something wrong with the problem?
I'm not sure, actually. You had an option to flag a problem?
Yeah, like gives you like a little arrow in the corner of it, and you're just like, it's looking at what you're doing.
I'll check. I don't know. I haven't noticed it.
Because I was hoping that it would be like, oh, like I need more help on like this kind of problem or something. And hopefully it doesn't mark it down as like, because I know there's like another class where it's like, oh, if the equation's wrong, just mark it down. And I was like, what?
No, I know what you're saying, but yeah, I don't know if it does that. I'll see.
This is the actual like test for you, two problems. Two of them that I just didn't answer at the time, but another two that I partially answered on like the written portion. And you can like see my work, like where this is a certain point that I just kind of like stopped. I did write it down to give like more specification into it that
Mhm.
I forgot like the rest of the stuff.
Oh, okay.
I'm not sure if that's still working out towards being partial.
Yeah, I might give you some, maybe more points since it's, halfway there or something. We shall see. A lot of grading to do. Yeah.
For the correction, you would need any factor import.
No, just do the corrections. Let me give you a definition here. For all positive numbers x, if on the calculator or on homework problem or whatever, if you see no base written, it's assumed to be the common log, which is base 10. So the one on your calculator, it says log, that's base 10. The ugly equal sign. For all positive numbers x, ln x is equal to log e. Thanks. You don't have to do that. Appreciate it. Log base e of x. So we just start a new section, Crystal. So the ones on your calculator are log x and ln x. ln is just specific to base e. And this is specific to base 10. That's it. I gave you definitions for general logs in the last section, base A, meaning A could be anything. But if A is specifically 10 or E, it's these. We use those the most. That's why there's kind of a shorthand. That's the only reason. They're special, but they're not. That makes sense.
So the second.
Mhm.
The second formula. I am one. Where is it? Okay.
Oh, LN. This one. Yeah, LNX. So in your calculator, you'll see it.
Oh, I see.
Right, LN right there. That's the natural log, base E. And this, the one without any base is assumed to be 10. So that's what I'm saying here.
So that's where that log comes in. Now
Yeah.
this right there.
Maybe, we'll see. I'll put the fan on. Yes. Right here, the last one. Is LNX equal to log base E of X. This is it's an E at the bottom. I think you can. There a button on there? Thanks. Yeah, so if you see this LN, it's just saying that it's just a log with the base E. That's it. All right, change of base theorem is just a formula. It's pretty straightforward. This one you for sure will use a calculator. So for any positive real number or numbers, X, comma A, comma, and B, where A is not equal to 1 and B is not equal to 1, the following holds. So log base A of X is equal to log base B of X over log base B of A. So basically what we're saying is, if you have a log of some base with whatever argument, you can change it to any base of your choosing, as long as you put X in this argument and A in this one. Okay. So if you see a question or a problem that has a base that's not on your calculator, you can just switch it to ln or base 10. If you have a log with a weird base, you can change it to something that is on your calculator because you choose the B. So choose like ln or something.
You're already given A and B,
So you're given this guy. And you put the X and A right there. And you choose whatever log you want. So you can make it base 10 or base E, base 5, whatever. I recommend using the ones that are on your calculator, like E or 10. There's not much to do in the homework. It's basically a calculator kind of section. So do you know how to plug it in is the only real question.
Can you show us, like, on the,
Yeah, let me show you. Can you zoom in with the blind people? Okay. So the first few are just definitions. I'll let you deal with that. But here, see how they're saying log 585 minus log 354. It's just, you're just plugging this in. So plug this guy into your calculator, base 10, and subtract it. There's nothing else to do. I did not. I feel like, I don't know. I'm not sure.
He doesn't know, and she doesn't want to get her.
You can just text him, I guess, or see what he says. Okay, yeah, he might be busy. I don't know.
so
What'd you get?
when I put it in, it shows a parenthesis and I type it in. Am I supposed to close that parenthesis?
Yeah.
Okay.
Name. Anyway. Sorry, it changed when I punched in the answer. But yeah, you just plug it in there. This is what I got.
Where's the one that you had it just now? The
It's this one.
5, 6.
This is the one that was there before it reset.
So in entering the answer, what do you think? That one, or do you put that close in?
Round to 4 decimal places is what it says. Yeah, so I went to what?
2180.
2182. Right. Did it again. Damn it. We can only get it. So 4, that's the place. The right, bigger than it's 5 or more, so this becomes bigger. Let's cut the rest out. Only 2 is the answer you would put in.
Oh, that's an English.
Yeah, 4.4. Yeah, it's pretty much all you're doing. See, here's using ln. Pretty basic stuff. Here, use a fraction. Just round correctly and you'll be good. To work on your homework problems for this section. This is just calculator stuff.
The hell in? Right.
ln 8416.
Was it 4 to the right and it stayed 2?
Yeah, it'd be 16582. So 2 on the right, so stay 2. So you would put in 1.6582.
And just leave the decimal noise.
Let's try it. Let's try it out. 1.6582. Yeah. So use the rest of the time to do homework and or workbook. I'll hold off on the other stuff. Use change of base on this weird, I'm just gonna make it up. Log 2 of 7. So that's not on your calculator unless you have a very fancy calculator. So what you would do is change log 2 of 7 into a log of your choice. I'm going to choose ln just because I like it. My favorite log. No, it doesn't matter though. So the argument goes here, the base goes there. And at this point, you would use your calculator. So notice that these are separate, right? So the ln7 parentheses divided by, it's not inside the ln.
Wait, so when you type in ln, then we gave you the parentheses space.
So put parentheses on top and bottom just to be safe. You should be good. Oops, division, right? So top part divided by bottom part. If I do it that way, oops, it will always be correct. That is the only other type of problem you'll see. The rest are pretty basic. If it said 4 decimal. It would be,
Or you said for them, they would be assumed to be 4 decimal places.
yeah, whatever it tells you.
Oh, so.
Last time it said 4, so. This one, let's see. Final answer to 4 decimal places as needed. It'll tell you, this question I made up, so,
Oh, okay, I thought that was like a general rule of thumb too. Okay.
no. Rounding depends on either their directions or significant figures. Like if we're building spaceships, then it's very important, it all depends on sig figs. But since we're just doing general stuff, we can choose. And they chose 4. Like I know chemistry gives you a lot of crap about significant figures because they're actual units or measurements. You can't introduce more accuracy if you don't, if you did not originally have it when you first started. If you only have 2 decimal places, how did you get 4 later, You shouldn't. Yeah, it's like, doesn't make sense. Same with physics. You add more details, it'll throw off the whole thing. It'll be less accurate.
I don't know, you said that spaceships, I mean, it's not like an asset. For whatever reason, method that has to really gets like proportions of like tax dollars, like a penny of the dollar.
Yeah, they used to be better funded. Kind of sad they defunded them over the years.
I'm like, is it a single back?
Is a penny every dollar you said?
Yeah, for every dollar, like on like that you receive something like tax, you only get like a penny of like cent into it. For like the military, I think you get like 50 cents.
The military gets a ton. I think maybe too much.
Yeah, it's for, and then like whatever else the dollar is like about each per dollar of like tax money, it's divided up into all the other like education, fund, other.
Yeah.
Yeah. No, yeah. Oh, you're talking about like if we assume the entire budget of America is $1. Is that what you're saying? Oh, okay, I get you now. Yeah, 50 cents is about right.
I was just looking at it, that compared to- and that's what the one that I found.